Here we go. Okay. Remember, we have a test over chapter 6, part. Is it part 1 or part 2? Part 2? No, part 1. Yeah, because we're on 4, 4, 4, 5. 4, 1, 4. Yeah, so 4, 1, 4, 2, 4, 3, 4, 4, 4, 5. So 5 sections. Okay, it's going to be on Delta Math. It's going to look very similar to your homework. It's the last one of the semester, so make sure we get it done. For those of you that watch this video, great. For those of you that don't watch the video, well, obviously you have no idea what's going on, because how else can I talk to you? Okay. So factor by grouping, it's a little bit different. Okay, let me get into it, share the screen for you. So we've done factoring already. We've factored quadratics. We factored cubics when we take out a monomial. We did that last Friday. And now we're going to do something a little bit weirder. I want to say weirder because it is kind of weird. Okay, you have to factor 4 terms. How do we share screen? God, I'm so bad at this. All right, here we go. Okay, so here's what we want to do. A little bit blurry. I don't know why it came out this blurry. I want to rewrite it. I am going to rewrite it. Okay, so what is it? 6ax. No, I'm not going to rewrite it. We can see that, right? Hopefully. Kind of a little blurry. That's all right. Okay, here's the deal. Okay, so we just did monomial factoring. So that takes out, what's a monomial? Monomial is a single term. Take it out of all of the other terms in the equation. Okay, that's what the whole point of it is. Okay, like you get something that looks like this. X squared or x cubed plus 6x squared plus 7x. We factor out a monomial. We factor out an x. So this becomes x times x squared plus 6x plus 7. Okay, remember that's monomial factoring. That was your Delta Math assignment. Okay, so today's factor by grouping. What we want to do is factor by grouping, and we're going to have 4 terms. Okay, so we're going to have 4, so it's going to look a little bit different. So here's what we want to do. We want to group the first 2 terms. I am sick. I don't know if it's COVID. I have no idea, to be honest with you. Okay, I am sick, so if I sound a little weird, that's why. Okay, let's group the first 2 terms. Let's group the final 2 terms. Okay, the last 2 terms. Why are we grouping them? Well, can we take a single factor out of all 4 of those terms? No, right? You can't take a 3 out because 3 doesn't go into 14. Okay, you can't take a 5 out because 5 doesn't go into 14 and 6. So here's what we got to do. We got to factor by grouping. So we're going to group each 2 terms and take a monomial out. And then we actually get something that's pretty cool. Okay, so we want to see what we can factor out a monomial, okay, or a combination of the first 2 terms. Well, I can factor out what can we factor out? We factor out a 2, okay, a 2x. We could factor out a 2x out of both these terms, right? So we get 2x times 6 divided by 2 is 3 minus 7. Okay. Now, the other 2 terms, what can we factor out of both? Well, that one's easy. It's a 5, right? Okay, so we're going to be left with plus 5 on the outside, and the inside we're going to get 3a minus 7. Okay, here's the cool thing. All right. These 2 red binomials are exactly the same. That's that's kind of the goal of factor by grouping. Okay, we want those to be exactly the same because here's the deal. Now we're going to treat this like one big equation. And what can I factor out of both of these? Here's the first term. Here's the second term. What can I factor out of both those? Okay, well, I can factor out the highlighted green binomial, right? I can factor that out. Between the 2x and the 5, I take off the 3a minus 7. Watch. Here's the different part. So I'm going to factor out this binomial. Okay, so that one goes away, that one goes away. So here's what we're left with. We're left with 3a, put in parentheses, 3a minus 7 times, what's left? 2x plus 5. Done. Okay, that's totally done. That's the whole point. You want to factor out the binomial. You want to get the same binomial in both of those terms so you can factor it out. All right, is that factored all the way? Can we go any further? No, right? That's factored completely. Okay, so we're not solving yet. So we're not doing anything. We're just rewriting and factoring, simplifying. Okay, let's look at number 2. So once again, oh, I sound terrible. That's all right. We'll power through it. Okay, once again, we need to group the first 2 terms and group the last 2 terms. Okay, what can I factor out? What monomial can I factor out of the first 2 terms? Well, I can't. 6 and 5 don't have any common factors, right? So that's 1. But I can factor out a b cubed. Okay, so I have b cubed. What am I left with on the inside? 6b plus 5. Yep. Okay. Now, here's the deal. We want to get the same binomial in both of our terms. So what can I factor out of the final 2 terms? Okay, what can I factor out that'll get me 6b plus 5? Okay, think about it. How do you get to 6 from 24? You divide by what? 4, right? But here's the deal. If I take a positive 4 out, I'm going to get a negative 6b. So why don't we take a negative 4 out? Watch what happens. I'm going to take a negative 4 out. Okay, so negative 4. Then I'm left with a positive 6b plus 5. Okay, now we're good to go. It's the same thing as the other one. I factor out this binomial. I factor out this binomial. I am left with, so I'll do it again. So that's what I'm taking out of both these terms. Boom. So I'm left with 6b plus 5. And what am I left over with? What am I left over with on the inside? Cannot talk today. B cubed minus 4. Okay, I'm Michael Jordan in the flu game. Sick. Absolutely sick. That's all right. Power through. Okay. Can I factor it any further? I can't, right? I cannot. So we're done. Okay, not too bad. Not too bad at all. Okay, let's do number 3. Once again, same process. Group the first 2, group the second 2. Okay, what can I factor out of both the first 2 terms? I can factor out in x squared. Christmas colors. Okay, if I factor out an x squared, I'm left with x to the first plus 4. Okay, now remember, I want x plus 4. What can I factor out of these final 2 terms to get x plus 4 left over? Well, you can get 6, right? I can factor out a 6. I really wanted to change colors there. Okay, let's factor out a 6. What am I left over with? X plus 4 on the inside. Okay, do we have the same binomial? Yeah, we do, right? Right here and right here. So let's factor them both out. Then we're left with x plus 4 times x squared plus 6. Donezo. All right, we factor completely. We're done. Okay, that's as far as we go. All right, now let's see what happens when we get 3 binomials, 3 factors left over, like at number 4. Watch this. Okay, it's the same process. Group the first 2, group the last 2. What can I factor out of the x cubed plus 2x squared? I can factor out an x squared. So we have x squared on the outside. What are we left with on the inside? X plus 2. Okay, now I want to get x plus 2. I want to turn this into x plus 2. So what do I got to factor out? Do I just want to factor out a 36? No, right? Because we get a negative x. I want to factor out a negative 36. Then we're left with x plus 2. All right. So let's rewrite it. Let's take out the x plus 2's. Just make them 1. X plus 2. Put it out in front. Times, what am I left over with? X squared minus 36. Okay, now I've asked you, are we factored completely on the last 3 we did? And the answer was yes, right? Are we factored completely in this? Can't we factor x squared minus 36 more? Yeah, we can, right? I'm still going to have the x plus 2. Okay, we actually talked about this. This is actually special. This is called difference of two squares. You like my square? Okay, difference of two squares. Okay, so here's the deal. Remember, this factors to x plus 6. Then what else? See how we have no middle term? So what does that mean? That means the x's, the single x's, have to cancel, so it's got to be x minus 6. Okay, that is done. Factors completely. That's called difference of two squares. If you want to memorize it and know every time it's going to end up like that, like if I got something like this, x squared minus 49, that's also difference in two squares. Vx plus 7, x minus 7. Okay, what's another one? I don't know. Let's do 25. X squared minus 25. Okay, then we'll get x plus 5 and x minus 5. If you memorize those or just know it, right, it's a lot faster than trying to go through and think, well, what terms can make this middle term drop out? Okay, difference of two squares. All right, let's get into number 5, but here's the deal. We're actually going to solve number 5. And I think I'm only going to show you one of them. The rest are on your Schoology. I'm fading, getting tired. Just sick. I don't know what it is. We'll see. Fingers crossed. Ooh. Okay, so we want to solve. So the first 4 we did, all we did was factor, right? Factor and simplify, no big deal. Okay, now we want to solve. But remember, when we're talking about factoring and solving, we're talking about zero product property. Okay, remember we get to our final factored form, we set each factor equal to 0, and we solve for x. That's what zero product property means. All right, let's look at the first 2 terms. What can I factor out of both those? I can factor out at what? X squared, that's it. Okay, so I factor out x squared. I'm left with 2x plus 3. All right, now remember, on the final 2 terms, I want to get 2x plus 3. So what do I got to do, huh? What do I got to factor out of the final 2 terms to get 2x plus 3? I got to factor out a negative 25. Okay. If I factor out a negative 25, I'm left with 2x plus 3 on the inside. Okay. We have the same binomial, so we can factor it out, put it out front, times x squared minus 25. Is that factored completely? No, I just did it, right? It's the difference of 2 squares. Okay, so we can go one step further. We get 2x plus 3 times x minus 5 and x plus 5. Difference of 2 squares. All right, now, but remember, I said solve, right? So we need to set, this is a zero product property, set each of these factors equal to 0 and solve for x. Well, we could do that in our head. Okay, do I need to go through and show it? No, not really, right? This first term out here is going to be x equals, I subtract the 3 over, divide by 2, I get negative 3/2. That's your first 0. Okay, your second 0 is going to be x equals positive 5 and x equals negative 5. Then we're good. Okay. What if, I'm done with these notes, dude, so you can shut the video off if you don't want to hear me nerd out real quick. What if I did this? Let me get this out of the way. There we go. What if I went to Desmos, it's right here, and plugged in that problem? Let's see what we get. So 2x cubed plus 3x squared, 2x cubed plus 3x squared. What was the other one? Can't remember. Minus 50x minus 75. Okay, this comes back to what is the point of all this, right? The point is to find the factors, right? binomials listed out, factored all the way. The other point is to find the zeros, right? We just found the zeros. We had x equals 5, x equals -3/2. That's what this is. And x equals -5. Remember, when we are finding the zeros, we are finding where the graph crosses the x-axis, okay? Where the y values are 0. Could you plug all these into a calculator or into Desmos and solve for zeros? Probably. Okay. But it's good to know how to do it by hand on a Delta Math test. Hey, use your tools. Use what you got. All right, guys. Sorry if that was a little crappy. I know I got low E. I'm sick. I'm sick as a dog. But I'm a tough dog. I'm a work dog. Woo-hoo. Yeah, I just barked. All right, peace. I'm out of here before I start going crazy.